Hello out there to you. In this video, we're going to use graphing calculator to solve this monopoly problem. We need to do a little bit before we put it in the graphing calculator, which is a free application you can use. So we've got our quantity, which gives us our demand function. We've got total cost, which gives us marginal cost, and we're really looking for profit maximizing price. Let's also find profit maximizing quantity. And then let's also find profit. We'll often use pi for profit. So first thing we want to do to get profit maximizing price, we need to find where marginal revenue equals marginal cost. So marginal revenue is going to come from this function here. It's easiest if you rearrange it so that we get an inverse demand function. You'll hear that in a lot of classes. An inverse demand function is just anything where the price equals something. Here it's quantity equals something. So I need to rearrange that. So let's do that. So I'm going to change all this so that it's quantity equals 100 minus 1/5. It's just, I like fractions better than decimals. So it's the same function. I'm going to move this over to this side of the equation. And oops, I forgot the P. And then move the quantity over to that side of the function. And now you see why I did that, so that I can just multiply a 5 times this, and that goes away. Let me show you how to do that. So that becomes 5 times 1/5. Those cancel out, and then we've got just price. The rest we can do in our head. 5 times 100 is 500. 5 times 1, there's a 1 on that Q, is 5Q. So now we've got our inverse demand function. And there's a trick. Whenever this is linear, rather than doing calculus, you can just find whatever this coefficient is. In this case, it's -5, and multiply it by 2, and that'll give you your marginal revenue. So that only works if it's linear. But so in this case, it's minus 10Q. Okay. Now to get marginal cost, what we're going to do, we do have to do the calculus. So this is a constant, so it doesn't matter. That's the fixed cost right there. So it doesn't matter in terms of marginal cost. I pay attention to this. So each unit is going to increase our cost by 60. So if you produced 2 units, it would be 2 times 60, 3 units, 3 times 60. See, it's going up by 60. So you can kind of reason that that would be the marginal cost. But to use the calculus here, this is q to the 1. We're going to take partial derivative, multiply that exponent by that 60, and then we're going to take away that exponent here. So this becomes like q to the 0. Q to the 0 is equal to 1. So then it would be 60 times 1, and so that's where we got the 60. So now I've got marginal cost and marginal revenue. I'm not going to do any more algebra. I'm just going to plug that in the calculator. The other thing that would be interesting to see on the calculator would be average total cost. So to get this, you just take total cost and divide it by quantity. So here, our average total cost is going to be 10 over Q, just dividing by Q, plus 60 over Q. But 60 over Q, 60Q over Q is just 60. So I'm going to take these 3 equations. No, I need 4 equations because I need the demand function too. Into Desmos, and then we're going to graph them and we'll see the answer. Very easy. So now when you use a graphing calculator, it doesn't really know that you're doing economics. So what we're going to do is we're going to swap out anytime you see Q, use X, because that's on the X-axis. And anytime you see P, or price, we're going to use Y. So swap all of those out. Okay, so you're going to see me do that this way. Let me make this skinnier so that you can just see what I'm doing here. Okay, so first one, it's your choice. You can do inverse demand function or demand function. In fact, let me prove that to you. So X equals 100 minus 1/5 Y. Okay, so we get that demand function. And I'm going to put in the inverse demand function, which is Y equals 500 minus 10x. That was the marginal cost function. Minus 5x. And you can see they're the same function. So you don't need them both there. Okay, we'll leave that one there as red. And then for marginal revenue, it is y, because this is like a price. So y equals 500 minus 10x, and there's our marginal revenue. And then I want y equals 60, that's marginal cost. And then I want y equals 10 over x plus 60. That's our average total cost. So I've plugged everything in. We're going to find profit maximizing price. It'll be pretty easy. Okay. I don't like all of these purples here, so you can change the colors if you click right here. If you don't want, maybe we don't want that one to be, maybe we want that one to be red and this one to be black. Okay, that's nice. And then I need these to be very different colors, so let's make that orange. Oh, they're kind of running together, so because the fixed costs don't really matter. Okay, so to find profit maximizing quantity, just go to where marginal revenue equals marginal cost and just click on it. And that other function is in there too. So it's, maybe I'm going to take out average total cost for now. There we go. So it says X and then Y. So the quantity, profit maximizing quantity is 44. And then since I know that, I can put in X equals 44. And then I'm going to follow that up to the demand curve. You didn't have to really put X equals 44, but if you do, it's easy. There's your price. So the answer is 280. Okay. And then if you want their profit, just put the put that function back in that I got rid of, which was 10 over x plus 60. So y equals 10 x plus 60. And it's a little bit off there. The cost then would be $60.22. And then, so profit would be the area of the difference between here and here. So it's a pretty big profit because it's 280 all the way down to 60 and then on those 44 units. So that's how to use Graphing Calculator to efficiently answer that question.